Good afternoon, everyone. Thank you for joining us today for the webinar entitled Robust Adaptive Edge Infinity Control Design for Heart Rate Regulation During Rhythmic Exercises by Dr. Zehra Baig, who has graciously joined us today. This webinar is brought to you by IEEE PF-KIET Student Branch, and we're extremely delighted to have Dr. Zehra Baig with us. She is an assistant professor in the Electrical Engineering Department at Ghulam Ishaq Khan Institute of Engineering, Sciences and Technology. She has also worked as an assistant professor at King Abdulaziz University in Jeddah. She has also completed her PhD from the University of New South Wales, Sydney, Australia. Her specialization is in control engineering. Thank you very much, ma'am, for joining us today. Before we begin, all our participants are requested to keep your mics and videos turned off during the entire session. We will have a question and answer session at the end in which you can raise your hand and the host will give you the opportunity to ask your question. You can also send any questions or messages to the host through the chat with your name and affiliation at the end. Please be attentive during the session as there will be a short and easy quiz at the end which will be sent to you through email along with the recording of the webinar. You will have 24 hours to attempt the quiz in order to be eligible for the certificate. The certificate will also be emailed to you within 1 week from today. Now, without further ado, we'll hand over the control to our most esteemed speaker, Dr. Zehra. Ma'am, the control is yours.
Thank you so much. My name is Dr. Zehra Baig, and today my topic is Robust Adaptive Edge Infinity Control Design for Heart Rate Regulation During Rhythmic Exercises. The thing is this, the beauty of the topic is it's related to the human body because we are controlling the heart rate. Heart rate is a kind of thing that is responsible to bear your load while you are doing walking, cycling, any physical activities. So keep in your mind, what do you mean by the rhythm? Rhythm is a kind of thing that produces from your own body. Any repetitive movement in your body is known as rhythm. Like if you are walking, your step counting is known as rhythm. If you are cycling, when you are paddling, basically this is known as rhythm. While you are doing other type of activities like rowing, any repetitive movement, it's known as rhythm. So the objective of this type of topic is the control input. What is the control input here? And the control input, in order to control your heart rate, is the rhythm of your body. Whatever you are moving, the movement gives you the increase in the heart rate because your body activity is responsible to increase the heart rate. Now, in general, what is the background? What is the actual background in order to increase the heart rate is while you are performing any kind of work like walking, when you are doing the walk outside the park or anywhere around, so what happens to your heart rate? Your heart rate get increased. So whenever you put some sort of load on your body and the heart rate get increased. And this may possible, it will increase up till that limit where you will feel some sort of fatigue. Obviously, if you are continuously walking, what happens to you? You got tired. So the thing is this, the important thing for your body is you should apply a control input to the body in order that you will not get tired, so your heart rate will move smoothly. And there are a lot of researchers in this area who perform such kind of work that control the heart rate based on the exercise intensity. One of the example is one of my colleague is Steven Su, and he's worked for walking exercise. What he did, he controlled the treadmill. He controlled the intensity of the treadmill in terms of the exercise intensity, and the speed is known as control input. To control the heart rate, what he did, The work of he did is he regulate the speed of the treadmill in such a way that it gives you the constant value of the heart rate. So if your heart rate get constant, so that means you are regulating in such a way the exercise intensity that you are getting the optimal heart rate. So the thing is this, keep in your mind, because there is a and how its relationship is this: the exercise intensity is directly proportional to the heart rate. As you increase the speed of the treadmill, your heart rate is also increased. So some zones are safest for you, some zones are not safe for you. For example, if you are performing the treadmill exercise and you are putting your speed at 4.5 kilometer per hour, and you are walking on the treadmill up till the point, for example, up till the 15 minutes of exercise, what happened? Your heart rate get constant value. Okay, let's assume when you increase the intensity of the exercise from 4.5 kilometer to 6 kilometer, and you will perform the similar exercise on treadmill, and your duration get increased, your duration is also 15 minutes. But the thing is this, your exercise intensity get increased from 4.5 to 6.5. What happened to your heart rate? The heart rate get increased. So the thing, it's clearly indicating the relationship between the heart rate and the exercise intensity is directly proportional. As you increase the exercise intensity, your heart rate get increased. So this is the one quantity that indicate that as you perform any physical activities, the heart rate get increased. So what about your body rhythm? For example, if someone is dancing, okay, what they are doing it? The dancing means they are moving its body in multiple position. They're moving the body with multiple position. And what happens to the heart rate? The heart rate is also increased. So that means any repetitive movement will also responsible to increase in the heart rate. As far as the previous literature reviews is concerned, there are various scientists who develop the controller in such a way that control the exercise intensity in terms of the speed, and they control the heart rate. For example, Quada, Sada, Steven Chu, and Teddy Anchin, these are the scientists who work for heart rate control, and they work for walking exercise, they control the heart rate. So the main motive is what the background they are saying, that the exercise intensity is responsible to increase the heart rate. Similarly, it happens with the cycling, and the Cooper is performed the work for the wheelchair. So some of those things, but their work is basically based on one type of exercise. One type of exercise, they are controlling the heart rate for walking. So the controller, whatever they design, they are specifically designed for only for one type of exercise. However, if you perform the cycling, the controller that work to control the intensity of the speed does not work for the cycling. So it's exactly, we need such kind of controller that work for any type of exercise. So what the American College of Sports and Medicine prescribe for multiple activity, they say that if you engage a person, in multiple activities, then it will perform a total physical condition. What does it mean? It's a very authentic uh, statement that gives you the example. You are involve your body for let's assume for doing walking, and then you are sitting somewhere and just you are moving your body up and down. So the thing is this, you are engaging multiple part of the body. So, however, one thing that is quantified as exercise rhythm is your body movement, how you are moving your body. So rhythm is a kind of thing that is responsible to increase the heart rate. Okay, so what we are doing, we in this research, we need such kind of controller that will work for any kind of aerobic exercise, because the aerobic exercise configure in terms of rhythmic activity. So rhythmic activity is directly proportional to the heart rate. And this activity and this rhythm can be utilized for any type of activity like walking, rowing, cycling. In this research, what I focus are three kind of exercises. The three kind of exercises are cycling, walking, and rowing. And I develop a controller that is useful for all these three kind of exercises and control the body rhythm in such a way that the heart rate get the steady state value. So this is my background. So now come back to the what is actually happening in order to develop such kind of system. Because you are an engineer, you need a real-time implementation. So one thing is, what is the mathematics behind? Being an engineer, you should have the idea, clear idea, what is the mathematics behind the relationship between the rhythm of the body and the heart rate. Wherever I'm writing it exercise rate, the exercise rate, if you look at here, the exercise rate is nothing, it's just a rhythm of the body. Okay, so ER is known as exercise rate, and this is equivalent to the rhythm of the body. It's defined the periodic movement of the body, and we have got the other parameter like heart rate. So what is the relationship between the ER and HR is a proportional relationship. That exercise rate is directly proportional to the heart rate. As you increase the body rhythm, your heart rate is also increases. The objective is to, because if you want to control such kind of system, you need to know what is the background of the heart rate and what is the background of the exercise rate. For that, we perform a lot of experimentation, and then experimentation, we achieve a data, and based on the data, we develop a model. So the objective, the first objective of this research is to develop the relationship between the exercise rate and the heart rate. And the second objective is to which controller you will be going to use in order to control the heart rate based on the periodic movement. So this is our second objective. The third objective is, because this thing, rhythm is a kind of thing that generate from the controller, and how you will be able to transfer to the human. So we need a system that is known as human actuating system that actuate the human in such a way that follow the rhythm. Once you follow the rhythm, your heart rate get controlled. So it is exercise independent system, means the controller does not know what type of exercise you are doing it, but the only thing that knows is the rhythm of the body. Once the rhythm appear in your ears or listen into your ear, you need to follow that rhythm in order to control the heart rate. So you need an interactive system that interact with the human. So interactive, whenever you need, so such kind of system is known as human actuating system. So based on that, you need to develop a human actuating system. And the fourth objective is, once you develop the human actuating system, you need to implement overall system. The overall system, how you will be able to adopt the system. The system is adaptive. The control algorithm, robust, adaptive H-infinity control algorithm. Why it is robust, why it is adaptive, and why we need adaptive control. This is very important to think about it. Look at your body. if you are performing some exercise, so how your body is behave with other person, because the physical condition vary man to man. Your physical fitness is different. If some girls are using the same similar exercises, the body fitness is different. So two similar persons having the same BMI might be possible, will perform in a similar manner. But the thing is this, if the person is very, so what happens? Their type, their intensity of the exercise is also vary. So with the variation of the exercise, because here the exercises also changes, because you don't know what type of exercise you are performing, your exercise is changing. You are, one time you are walking, one time you are cycling, and one time you are rowing. Your activity, your physical activity is changing, but your controller does not change. So that activity brings the change in the heart rate, and the heart rate varies differently. So the thing is this, you need a system that should be adopted to cater the problem that varies subject to subject. Subjects mean a person to person. So we need a adaptive controller that adopt the real-time parameters, and based on that generate the control rhythm in such a way that control the heart rate. So these are the 4 objectives of this project. So the first thing what we did is we need to perform, as I said, in order to develop a model, we perform different type of exercises. There are the 3 type of exercises. Look at here: walking, cycling, and rowing. And these are the intensity which we are using in order to analyze the relationship between the HR and the ER. If you look at here, what we achieve here is the response of the heart rate. The response of the heart rate here at the speed of 4.5 kilometer during walking exercise achieve a steady state very fastly as compared to the heart rate that achieve 5.5 and 6.5. So the thing is this, what in order to analyze the data for the in terms of the exercise intensity and the heart rate, we found that the system is not linear. The system is a kind of system that is non-linear, because the steady state behavior, if you look at the steady state here, it gives you the different value as compared to this. Also, the exercise intensity is increases linearly, but the heart rate does not increase linearly. So this information, we extracted that the different type of exercises also vary the response of the HR. So we need a kind of system that is adaptive, as I explained to you. We estimate a different type of parameter for various subjects, and we achieve those parameters. And these parameters tells you that the model that you are estimating at the moment, it will be very exercise to exercise, and also it is very subject to subject, means person to person. So it is conclusion what I explained it to you before. It's concluded in the experimentation that the subject variation is also changing the model parameter. If the subject is changing the exercise, the model parameter also changes. So the system must be adopted to cater such kind of problem. So this is the data analysis, what we achieve from the experimentation. Now, the base on that, we extract one thing from here, which I need to explain it to you. The system must have, here this is a second order time variant system. This is a kind of system which we need to estimate in real time. The parameter here, A1, A2, B1, B2, it's vary, because if you look at the chart here, these parameters are varies. Okay, so this structure of the model is same. The structure is same, but the model parameter is vary. So Thus, we keep the structure of the heart rate and the exercise rate same, but we are varying what we are varying the model parameters, and we are estimating these model parameter in real time. So this, whatever the parameter we extracted, we adopt those parameter, and based on that we decide what the controller do. And the second time after this assessment or this analysis, we develop a human actuating system. Human actuating system is in front of you. That's basically, this is a step indicator that shows that whenever the step indicator indicate red point, that means you need to follow the rhythm. If you are cycling, you mark one point and you should achieve that mark point constantly. Once you achieve that mark point, you are following the rhythm. Once you follow the rhythm, so what you are going to do, you are following the exercise rate, because exercise rate is your rhythm. So basically these are the indicator. If your actual exercise rate is greater than the value of what is desired by the controller, this indicator will slow you down. This is a slow indicator. If the exercise rate, if faster, you need to if you are slower and you need to perform a fast exercise, so this indicator will be switch on. And if you exactly follow the direction of this step indicator, that means you are following the exercise. So these are the system that illuminate the light in front of human human, that allow the human to follow the beat in such a way that the heart rate get constant value, what is desired by the uh, controller. So this is the representation of a human actuating system, and this system is developed in the lab view. So what is the background here? The main thing in order to develop a system is the estimation of the exercise rate. Here, if you look at the device here, device is known as triaccelerometer. The triaccelerometer gives you the cyclic motion or a frequency that you need to extract from the signal and estimate the time period of that rhythm. That rhythm will be give you when you estimate the time period, when you reverse the time periods, you will get the rhythm. Okay, that means this is a frequency, because time period 1 over t is a frequency. So this device, it's known as triaccelerometer. It's a wireless device that transmit the data from one point and then receive the data in the Bluetooth. And the system is developed by myself in the lab view, and the USB interface is available. And we extract the information from this device into the lab view, and then lab view see the cyclic movement, and we interfaced the MATLAB in front of in parallel with the lab view that extract the time period from the cyclic movement, and then we reverse it, that generate the exercise rate. So the estimation of the exercise rate is basically happens by using the triaccelerometer. For the student, especially for the student, because the bachelor student obviously perform the final year projects. It's one of the projects that you can perform in your final year, that if you are, let's assume you have a mobile, okay, you have a mobile and all the mobile has got a triaccelerometer, okay. So if you have a triaccelerometer, you can estimate the exercise rate based on your mobile estimation, because the cyclic movement of your mobile will give you the rhythm, and this rhythm you can interpret as exercise rate. It is not necessary that you will use a special kind of triaccelerometer, because this project is a kind of biomedical project and you need a very precise. But for the final year project, you can even use a triaccelerometer of your mobile to extract the ER, exercise rate of the body. And this will give you the cyclic movement. And after that, you allow the algorithm to perform some sort of filtering, and that filtering will give you the exercise rate. So this system I developed during my PhD. And after that, this most important thing is the heart rate measurement. The heart rate measurement, because we need two input. We need to deal with two things. One is the exercise rate, the other is the heart rate. So this is the heart rate. We use polar belt that extracted the R2R pulses, and that pulse is converted into the heart rate. After that, we perform the filtering and we get the heart rate in terms of the beat per minute. So this system is I developed and also in the LabVIEW. So these are all real-time implementation which we did during my PhD. So once you have got exercise rate, once you got heart rate, you need to synchronize in the computer in a laptop, so that both the data, input data as exercise rate and the heart rate data will appear in the laptop. So this is a system where I am achieving both value. One is the exercise rate, one is the heart rate. Once I got this value, now I will be able to see what will be my next step. So this is the block diagram of overall my project. If whatever you are saying here, it's look like you are achieving exercise rate from the physical device, you need to achieve the heart rate. These two parameters will go into the system identification. System identification, it's a kind of system that estimate the parameter of model parameter. If you look at the back, this is a generalized model. This equation is generalized equation. The parameter is A1, A2, B1, B2. These parameters you need to identify in real time because you need to perform a system that is adaptive, and the system is vary from subject to subject as well exercise to exercise. Now look here. So this is my block diagram, and this goes into the system identification. Based on the system identification, we identify the human parameter that shows the relationship between ER and HR. In real time, we compute the controller, and controller, once the computation done, we assign the controller here. Okay, so this is a controller parameter is achieving based on the real-time value of exercise rate and the heart rate. Now look at here. This is a targeted heart rate, means what is desired from your body. For example, if you want to maintain a heart rate of 130 degrees, 130 beats per minute, so you need to set the target HR equal to 130 beats per minute. And here you are measuring the heart rate, HR. So the difference of that HR or your target HR will give you the error signal. And based on the error signal, the controller will decide what to do. Either you want to be slowed down, you want to be fast, you want to be follow, or whatever you will do. So this thing, the controller is a decision maker, and that decide you to how your body will perform, either slow, fast, or follow. So this thing is your interpretation. And here, this complete thing, it's basically showing you the human actuating system. The controller gives you the exercise rate, and the exercise rate, whatever you are here, this is a measurement of the exercise rate. When you generate the error, if the error is negative, so what does it mean? You are behind the actual desired value. So what you need to do, you need to make yourself become speed up. So the indicator will be switch on and you will become fast. Similarly, if the exercise rate is positive, that means you are behind the value. So you need to be more slower. So exactly, if the error is 0 here, so you are following the exercise. So basically this part is nothing, is just a human actuating system that actuate, that allow you to follow your controller. So this is a part which I developed that is known as human actuating system. Now the thing is this, what we did, as I explain it to you in the block diagram, the first thing is the measurement of heart rate and the measurement of ER. After that, what we did, we estimate the model parameter. And once the model PA parameter identify, we develop or calculate the controller parameters. And after that, we assign a target ER that need to be followed by the human subject in order to regulate the heart rate. So this is the flow chart of the controller, the similar thing, and I don't want to repeat again, but actual flow of the controller is representing here. So this is a flow diagram. Now the thing is this, the most important thing for me is to design the controller in order to meet the requirements of the desired specification. So we develop our H infinity controller because H infinity controller has the ability to cater the robustifying effect. If someone parameter get vary, but the controller can justify. So we set up the value of the gains and design the controller that is used for initial minute until the parameter is extracted from your actual body. So what the recursive algorithm basically we are using here in order to extract the model parameter. The model parameter is extracted from the least square algorithm, and the least square algorithm, that is recursive least square algorithm, and that allow you to extract the model parameter, and that model parameter we fit into the controller and design the controller. So this is a structure of the controller. Obviously, if you look at here, these B's are controller parameter, B's and A's are controller parameter that changes in every 30 seconds. So we develop a controller and it's the parameters, only what we are doing it, we are changing those controller parameter. If the subject is changing the exercise, or if the subject is changing the exercise intensity, obviously the model parameter is changed. If the model parameter is changed, then the controller parameter obviously changed. So after 30 minutes of exercise, once the model extracted in real time, we develop a controller in real time and then fit it into the over block diagram in the lab view, and then estimate the targeted exercise rate. So before implementation, obviously we need to perform simulation. For simulation, we developed, obviously whatever the experimentation we perform, we extract the model, and that model extraction having two types of exercising. One is cycling, one is rowing. And these model are changing their parameter as I show you in the model slides. So it varies with the exercise rate. As exercise rate increase, the model parameter is changing. This is for the cycling, this is for the rowing. Now what we did, whatever the control algorithm we develop, we fix that algorithm and we implement that algorithm on these two type of exercise in order to simulate it, in order to check the variable, check the efficacy of controller. If you look at here, initially what over requirement, if I use my controller for cycling, that the controller should maintain 110 beat per minute. So the controller exactly achieve 110 beat per minute. After 5 minutes of exercise, controller change its behavior, a targeted value, or it reaches to the value which is approximately equal to 125 beats per minute during cycling exercise. And again, the control input changes, and then also the human subject achieve the heart rate which is 125 beats per minute. Similarly for for the step down or recovery exercises. Exactly when I switch the model from cycling to the rowing exercises, and then I simulate the response. This response is look like good, that the if you change any type of activity, but that you are achieving the heart rate that is required by yourself, whatever the demand is. Initially you need to perform 5 minutes of exercise at the beat of 110 beats per minute, and this after 5 minutes you need to achieve 125. Both exercises, even cycling and rowing, both achieve their target value. This is for simulation. Once I perform the simulation, I implement the system in real time. And after the implementation, I develop a protocol, and that protocol allow you to warm up for 1 minute or for 5 minutes. And warm up means the duration which I'm talking about when you are performing the exercise at the rate of 110 beat per minute. And after that we perform the exercise, which is little bit higher exercise intensity for 10 minutes. The duration is not it's 10 minutes, and so on. So if following are the subjects in real time, we select 6 subjects that performs this type of 2 exercises, 1 cycling and 1 rowing. And these are the ages, mass, and height of BMI of those subjects. So all of them are successfully achieved their heart rate as per defined profile, which is in front of you. Or once it achieved, that means your controller is satisfying the requirement and you are achieving the exercises, or the controller is able to switch between any 2 type of activities like cycling and rowing. And whatever the statistical analysis we perform for cycling and the rowing exercises, both gives you the optimal performance. And the most important thing here, the subjects, the heart rate of the subject are in the stable mode. Means if you look at the pose, when we analyze the pose of the model, they are all inside the unit circle, which means the system is stable and the human does not produce such kind of fatigue in order to achieve their heart rate. Uh, any Q, I think, so in the conclusion, yes, in this study, the adaptive HR regulation system has been developed that regulate the HR of exercising subject during any exercise of unknown type. The system tracks the desired HR profile using an adaptive edge infinity controller. An important feature of the design control system is the use of human actuator that have never been implemented before. The system has no information about the text type of exercise. The only available information is 2 things. One is the heart rate and one is the exercise rate. And the system is performed well for all 6 type of subjects. I'm handing over to you. So if you have any queries, just let me know.
Okay, thank you very much, ma'am. Now the floor is open to questions. If anyone has any questions, you can raise your hand and we'll give you the opportunity to ask them. Does anyone have any questions? You can raise your hands or you can type the questions in the chat and send them to the host with your name and affiliation.
Okay, one more thing which I am telling you very interestingly for the especially undergraduate students. For the undergraduate students, you can implement such kind of system, even from your own mobile. The mobile gives you the both 2 things, because in order to implement such kind of system, you need two things. One is the exercise rate and one is the heart rate. And you just need a headphone that plug in into your mobile that allow you to give rhythm. Okay, so rhythm, if you listen the beep from your mobile and you follow a body movements, and your heart rate get controlled. So this system is physically implemented even only from your own mobiles, but it's a complex system, but even your mobile is enough to implement the system. So any query, any questions, just let me know.
Yeah, that's very interesting. While the participants are thinking about the questions, I would like to ask a question from myself. Ma'am, it was quite interesting to see how you designed the entire controller by yourself. As an undergraduate student, we often come across these opportunities during our research where we feel that we have to design our own controller, and we either use MATLAB for that or we use LabVIEW. So, and most of the time we need a lot of data, some training data to see whether our controller is working perfectly or not, and then we have to implement some sort of error removing system. You can say that a controller within a controller. Can you give us some advice regarding what steps we need to follow when we go for designing our own controller?
Okay, the thing is this, yes, this is a good question because initially you don't know what type of experimentation you need to perform in order to extract the model parameter, and that model parameter will be used to develop a controller. Uh, the thing is this, either you perform your own experimentation, and you can discuss with me how you are performing the experimentation and develop your estimate your control model parameter using the least square algorithm. But the thing is this, if you face such kind of difficulty, and then I will be able to provide you a data that will at least for one type of exercise, so that you can see that how the exercise rate is behaving with the heart rate. So this data I can provide to you. You can extract the model parameter using the MATLAB. The thing is, this MATLAB at the moment it's initially good for you in order to develop a controller, and it's a simple project for the undergraduate. If you have a model parameters, if you have a data, use least square algorithm to extract the model parameter. Whatever the model parameter extracted, design a controller, even a PIT controller that implement in the Simulink, that allow you to show how the exercise rate control the heart rate. So this I can do for you. I can provide you one subject data for you, and you can see if you are really more interesting, then you have to perform your experimentation. And obviously experimentation required a lot of care, and because it is related to the human subject, so you have to be very careful. And you also have in your university, you should have some ethics department that allow you to do so. Because for example, if you allow a subject that exercise 7 km/h, so uska to baja baj jayega. You cannot do it like that. You should have some sort of ethics in your university that allow you to do the experimentation. If it is not like that, it's better, it is recommended to use the data. Whatever I have during my PhD, you can ask to me, you can get it from me, and then extract the model parameter and then design a controller in the MATLAB. But when you implement in real time, obviously for the real time implementation, you need to perform the experimentation based on those subject which you are targeting to design a controller for that particular subject. So obviously for the initial treatment, you should be very careful.
Thank you very much, ma'am. Thank you very much. Do we have any more questions from the audience? You may raise your hand and we will unmute you so that you can ask your question. You can also write down your questions and send them through the chat.
One
Abdurrahman, do we
question
have
in
any
chat.
questions in the chat? Yes.
How to trace heart rate?
How to
Trace heart rate.
track heart rate?
Trace.
Yes, how to track that.
Trace.
They must be asking about what kind of hardware we may use to trace the heart rate and get the output into our computer.
Target profile. Keep in your mind one factor. For example, your age minus 220. Okay. So this will gives you the maximum heart rate that is allow you to get it from the exercise. For example, if my age is 30, let's assume let 30, 40, whatever. So 220 minus 40. Okay. So this will give you 180. 220 minus 40 gives you 180. Okay. 180 is the maximum heart rate that is allow you to achieve during the exercise. Okay. So the thing is this, when you are performing the aerobic exercises or a rhythmic exercise, the 70% of that value you need to achieve in order to make the protocol of the exercise. If my age is 40, my 220 minus 40 makes you 180 and multiply 180 by zero point 0.7. So zero point 0.7, then you multiply 0 0.7. So whatever the value you achieve, that is your target heart rate during the exercise. Because otherwise you are not in aerobic zone. You are doing the high intensity exercise, and which means you are performing fatigue, or fatigue means you are getting tired and you will not be able to perform for the long duration of exercise. Forget about it. So whenever you think that you need a long duration exercise that allow you to make your life smoothly be for long duration, so whatever your age is, 220 minus age, and take the 70% of it, that will be your target heart rate that required during the exercise.
Thank you
And
very much. Okay.
One more question
So,
in chat.
yes, Abdurrahman, please ask.
What high heart rate affect on our automatic nervous system? What
this,
high heart rate affect on our automatic nervous system?
okay, autonomic nervous system, yes. As I said to you, 220 minus, this is a ACM suggested, American College Sport and Medicine. This formula is given by them. 220 minus age, it's a maximum heart rate for you. Okay. So if you increase from that limit in anyhow, the thing is this, your heart rate is not only responsible because of the fatigue or because of the exercise intensity. Heart rate depend upon many other parameters. Heart rate can also increase because of the body temperature. Heart rate can also increase because of your sudden shock. Someone listens some bad news. Okay. So what happens to your heart rate? It suddenly increases. So the heart rate is also dependent upon the emotion. Heart rate depend upon your body temperature, your physical condition, lot of things. Okay. It does not a direct indicator of exercise intensity. Okay. But what is your question that affect your autonomous or autonomic system? It's basically your maximum heart rate. If you increase from that limit, obviously your system get affected. Okay. So even if you are doing the fatigue exercise, high intensity exercise, you should be within your limit of your maximum heart rate that is suggested by the American College of Sports and Medicine, that is 220 minus age. Okay. So if you increase from that limit, obviously you will suffer in any scenario. If your heart rate get increased from that limit, even sudden shock, some emotional feeling, whatever. Any other question, please?
Okay, thank you very much. Now, do we have any more questions?
No.
Okay, then. We would like to present, ma'am, we will move towards the closing of this session. If we don't have any more questions, okay. Yes. So, ma'am, can you please stop sharing the screen so that we can share something from our side?
Okay.
Thank you very much. Abdurrahman, can you please share the screen? Okay, ma'am, this is a very small token of appreciation from our side. The webinar was very interesting, and it was quite nice to understand how you explained such an advanced topic in very simple terms, and the entire webinar was very informative, and it was very wonderful to hear about how an entire controller is designed, especially for something like heart rate regulation. So thank you very much for your time and your efforts in explaining this topic for us and speaking through our platform. We are extremely honored to have you with us on board.
Thank you so much.
Now, we would also like to thank all our participants for joining us today, especially the participants who joined us from Qatar and Tunisia. So thank you very much for your time and for supporting our webinars. We hope that you will continue to join us in our future events. Your certificate, you will get the quiz link within a few days, and you will have 24 hours to attempt the quiz. After that, the certificates will be emailed to you. So thank you very much for joining us, and we hope to see you again soon. This is
Thank you.
goodbye for now.
Thank you.
Allah Hafiz.
Thank you very much, ma'am.
Thank you very much, ma'am.